Alright, so there's this new term buzzing around the tech world, and it's a big one. It's called vibe coding. The promise you can build an entire app just by describing it. But here's the catch. It's also making some of the world's best engineers really nervous. Today we are going to decode what it is, why it's so polarizing, and what it can mean for the future of software. And that really gets us to the heart of it, right? Is AI making coding obsolete, or is it just helping us create a bigger, more complicated mess? I mean, are we truly about to democratize software creation for everyone, or are we just, building a future on a foundation of broken, insecure code? To figure that out, let's really unpack the arguments on both sides. Okay, first up, let's talk about the promise. Why are people, especially in places like Y Combinator, so unbelievably optimistic about this new way of working? What is the vibe here anyway? So at its core, vibe coding is actually pretty simple. You just describe what you want in plain English, and an AI handles all the complex syntax. I love this analogy. Think of the developer's role shifting from a bricklayer who's meticulously placing each individual brick to an architect. The architect designs the blueprint and directs the construction crew, which in this case is the AI. And this quote from a Reddit discussion, it just captures the excitement perfectly. The big promise here is that vibe coding massively lowers the barrier to entry. Imagine you're a founder. You have a brilliant idea, but you don't know how to code. Well, now you can build a minimum viable product, an MVP, that first base working version of your app to prove your idea is worth something. And you can do it all without having to find that elusive technical co-founder. This table here, it really breaks down the fundamental shift. Think about it. Traditionally, a developer's input is precise code, but with vibe coding, it's natural language. That completely changes the game. The developer becomes less of an implementer and more of a guide, a tester. The learning curve is way lower, and the speed for whipping up early prototypes is just incredible. But as we're about to see, that speed can come with some serious hidden costs. And yeah, that brings us to the other side of the coin, the peril. Because for every enthusiastic founder you see, there's a seasoned engineer raising a giant red flag. And look, this backlash isn't just about people resisting change. No, it's rooted in years, decades, even of experience cleaning up really messy code bases. This comment from that same Reddit thread just sums up the fear perfectly. The value is that we are basically encouraging the creation of fragile, unmaintainable software, but on a massive scale. It's code that's built by people who might not understand the why behind it all. You know, the crucial stuff like security, performance, scalability, and that can lead to some huge problems down the line. And believe me, this isn't just a hypothetical risk, it's happening. The news stack reported on a real-world example where a team used AI to ship a feature super fast, but later they discovered a massive security hole. Turns out the AI had just forgotten a critical authorization check, and nobody on the team caught it. The feature looked fine on the surface, but underneath it was completely fundamentally broken. So the crucial point here is that this whole move fast and break things approach, when you supercharge it with AI, creates some really predictable problems. You end up with brittle code, security gaps, a tangled mess of logic. It's a nightmare to fix later, and that isn't real progress. It's just racking up what we call technical debt. Think of it like taking out a high-interest loan on your code. You get the cash now, but the payback later is going to be painful. And with AI, you're accumulating that debt at lightning speed. There's this classic programming saying that is more relevant now than ever. It goes something like this. Debugging code is way harder than writing it. So if you are writing code at 100% of your own capability, you are not actually smart enough to debug it. Now think about this: large language models (LLMs), they let you go past 100%. If an AI generates code that's more complex than that you would write yourself, how on earth are you supposed to find and fix the subtle bugs hiding inside? You're basically flying blind. So what's the answer? Do we just throw away all these powerful AI tools? Well, not necessarily. The conversation is now starting to shift toward a middle ground, a more mature, disciplined approach to working with AI. This is where it gets interesting. And that brings us to this idea of vibe engineering. It's about using AI not as some magical black box that just spits out code, but as a really powerful assistant that operates within clear boundaries that you set. The human is still the architect, right? You're the one providing the structure, the context, and the constraints. This comparison just shows the difference perfectly. A vibe coder might give a super vague prompt like, "Hey, write a Boolean function," but a vibe engineer, they provide specific technical context. They are referencing existing functions, pointing to security patterns. The AI isn't just making stuff up out of thin air. It's being carefully guided to integrate its work into an existing, well-structured system. It's a world of difference. So what does this actually look like in practice? Let's take a quick look at the kinds of tools that are out there enabling both the casual viber and the professional vibe engineer. Okay, so the tools for this really cover a whole spectrum. For beginners, you've got something like Google's AI Studio, which can literally take you from a single prompt to a live app. It's wild. But for the pros, you have a tool like Gemini Code Assist that integrates directly into their code editor. It basically acts as an AI peer programmer, a virtual partner sitting next to you, suggesting code, answering questions, and just helping you work smarter inside a project you already built. But regardless of which tool you are using, the fundamental workflow is this tight iterative loop. It's a cycle. You describe your goal, the AI generates some code, you execute it and see what happens, and then you provide feedback to refine it. It really is like a conversation between you and the machine, and you just keep going back and forth until the software does exactly what you want it to do. So, okay, we've got these new tools, these new workflows, and it's all leading to a massive shift. And this innovation, it naturally brings up a much bigger question. If AI is the one writing the code, what does it even mean to be a software engineer in the future? Well, the emerging consensus seems to be that the most valuable skills are shifting away from the keyboard. It's becoming less about how fast you can type code and way more about your ability to think at a higher level. Like, can you spot bad code when an AI generates it? Can you design a whole system that can actually grow and scale? Are you good at guiding and reviewing the AI's work? These are the skills that are going to truly matter. And really, that seems to be the ultimate takeaway here. As the physical act of writing code becomes more of a commodity, something AI can just do, the true enduring value of an engineer is shifting. It's no longer about banging out lines of code. It's about judgment. It's about architectural vision. And it's about that uniquely human ability to ask the right questions. The future, it seems, isn't about replacing engineers with AI. It's about creating a whole new kind of engineer.